my dear children, so I am back with the second video of the video series on triangle and its properties, and in this video we are specifically going to talk about a very important property which is called the exterior angle property. So let us look at the property and we will also solve quite a few questions based on this property. I am Roshni from Learner Hub, the free learning platform where you get to study everything about maths and science absolutely for free at learnerhub.com. So are we all ready to learn? Let's get started. So now we are going to talk about something very important and very interesting as well. That is the angle sum property of a triangle. Now this is a very important and very basic property of any triangle. And this property says that the sum of the three angles of a triangle is equal to 180 degrees. That's so surprising, right? It doesn't matter which triangle it is, whether it is an acute angle triangle or it is a right angle triangle or obtuse angle triangle. For any triangle, this is going to hold true. That is, you measure all the three angles, sum them up, it is going to be 180 degrees. You don't trust me? Okay, then let's start measuring angles. So you take different types of angles. Any triangle. Let's say here you have this triangle ABC. So when you measure this angle and this angle, the sum of angle A, B and C comes out to be 180 degrees. In fact, I want you to try it out for yourself. Open your textbook, look at all the triangles, start measuring them with protractor and you see that the sum of the three angles is always 180 degrees. Any kind of triangle, whether it is, now if you talk about a right angle triangle, so this angle is 90 degree. So in a right angle triangle, the measure of angle A and angle C is such that the sum of angle A and angle C is also 90 degrees, so that the total is 180 degree. Similarly, you talk about an acute angle or an obtuse angle. So in obtuse angle, this angle is obtuse. So it is like greater than 90 degree. But at the same time, angle C and angle A are very small. So that again, the sum can still remain as 180 degrees. So this is a very basic property of a triangle and a very crucial one as well. In fact, with this, you can also think it in this way that you remember I told you that in a right angle triangle, only one angle can be 90 degree. You can never have a triangle with two angles 90 degree. That's because if two angles are 90 degree, then the sum of two angles will be 180 degree. So what will happen to the third angle? Third angle can't be zero, right? Therefore, you can have only 190 degree in a triangle. So now let us try to prove this, that how can we say that the sum of three angles is always equal to 180 degrees. So let's assume that we have a triangle ABC. Now in order to prove this, so what is our aim here? Our aim is to prove that angle, let's name these angles as angle 1, let's call this angle 2 and let's call this as angle 3. So we have to prove that angle 1 plus angle 2 plus angle 3 is equal to 180 degree. So for this purpose, what we do is we draw two parallel lines in this way, like such that one line passes through the vertex A and the other line passes along the side BC. Let us call these lines as L and M. So we draw these two parallel lines. So once we have drawn these two lines, what do we see? We observe a few more additional angles. Now the moment we have drawn these lines, we have this angle. Let us call this angle as angle 4. Let us call this angle as angle 5. Now, what we have done? So as per our construction, we have constructed L and M such that L is parallel to M. Now since L and M are parallel, therefore we can say that angle 4 is equal to angle 2. This is angle 4 and this is angle 2. Can you tell me why? That is because these two are alternate angles. You remember we learned about the alternate angles in our previous lesson, that if two lines are parallel and if you have a transversal. So in this case, AB is like a transversal for parallel lines L and M, and angle 4 and angle 2 are alternate interior angles. So these are alternate angles. So for parallel lines, alternate angles are equal. In a similar way, we can say that angle 5 will be equal to angle 3 because these are also alternate angles. Now, one very simple tip to remember or to recognize alternate angle is you will always observe that alternate angles always lie within this Z. So, you have a capital letter Z and one corner of the Z you have one alternate angle and the other corner you have another angle, and these two are always alternate angles. So here you see this forms a Z. Here also this forms a Z in the reverse direction. Right? So whenever you see this Z, you tend to have these alternate angles. So in this way you can say angle 4 is equal to angle 2 and angle 5 is equal to angle 3. Now one interesting observation that we see here is this angle 4 plus angle 1 plus angle 5, all of these together form a straight line. That is, all of these together make 180 degrees. So we can say angle 4 plus angle 1 plus angle 5 is equal to 180 degrees. Why? Because they form a straight line, and straight line means straight angle, which is 180 degrees. Now we have seen that angle 4 is equal to angle 2. So we can write it as angle 2. Now angle 1 we will leave as it is. Angle 5 can be written as angle 3. So what did we get? We found that angle 1 plus angle 2 plus angle 3 is equal to 180 degrees. So this is what we wanted to prove, right? So we proved that the sum of three angles of a triangle is always equal to 180 degrees. So till now we have been focusing only on the angles which are located within the triangle. Now we are going to talk about the exterior angles in a triangle. Now looking at the picture on the screen, can you guess what are these exterior angles? I'm sure you can. Yeah. So when you look at the screen, you see an image where you see a girl inside the house who says I'm inside, and there's this little boy who is outside and he says I'm outside. So how are they different? How are their positions different? So the girl is located within the house. So she is inside. So she is nothing but just like the interior angles of the triangle, where the angles are located inside the triangle. Whereas this boy who is outside is just like the exterior angles of the triangle, where the angles are outside the triangle. So the angles, when we actually try to define exterior angles, these are the angles which are formed by the sides and vertices of the triangle, but they are located outside the triangle. So that is why they are called exterior. Exterior, it is derived from the word external. External means outside. So let us look at this triangle. Now in this triangle, so let us name the vertices. Let's say this is A, this is B, and this is C. So for this triangle ABC, if I ask you which are the angles for this triangle, so we normally focus on these angles, angle A, angle B, and angle C. And where are they located? They are located within the triangle, right? So they are placed inside the triangle. So these are interior angles of the triangle. Now if I ask you which one would be the exterior angle? So do you think any other angle which is located outside? Let us say if I draw an angle like this, do you think this is an exterior angle of this triangle? Definitely not. So for an angle to be an exterior angle of a triangle, it is important that the angle is formed by the sides and vertices of the triangle. That means the angle has to be formed on either of these points, either on A or C or B. So let me give you one example. Let's say that if we extend this arm BC, so we extend it further. So what happens? There is another angle which is formed here, right? So now let's look at this angle. This angle is formed inside the triangle or outside the triangle? Yes, it is definitely formed outside the triangle because inside is this blue region. So this is formed outside. But at the same time, it is formed on the vertex of the triangle, that is, it is formed on the vertex C, and it is also formed by the sides of the triangle. So which are the sides of this angle? This is one side AC and this is another side, if we call this point as CD. So AC and CD, they form this angle. So CD is nothing but an extended part of BC, which is a side of the triangle. So basically when you look at this angle, this is an exterior angle for this triangle. So for an angle to be an exterior angle of a triangle, there are three conditions. First, it should be formed on one of the vertices of the triangle. Second, it should be located outside the triangle. Third, it should be formed by the sides or extended sides of the triangle. So that ways, can you tell me how many more exterior angles can you make out of this triangle? So what could be other exterior angles in this triangle? So let us look at more possibilities. Now instead of extending BC, let's say if we extend this arm AC. Do you think we make an exterior angle? Yes, we do. Look at this angle. This is an exterior angle. Because this is formed at the vertex, this is formed by the sides of the triangle. One side is BC, the other side is extended AC. Do you think that this angle would be an exterior angle? This angle, do you think this would be exterior angle? No. Can you tell me why? This is also formed on the vertex of the triangle, but is this formed by a side of a triangle? This angle is actually formed by both extended sides. Therefore, this angle will not be considered as an exterior angle of a triangle. So, for an exterior angle, one side has to be the side of the triangle and the other side could be an extended side. So, that is how we determine which one is an exterior angle of a triangle. Let's say when you extend this side. So, this is an exterior angle. Similarly, when you extend this side. So this is an exterior angle. So, and similarly on the vertex B as well. So just remember these three things. An exterior angle has to be formed on the vertex of the triangle. It should be located outside the triangle. And it should be the two arms of the angle. When you look at the two arms of the angle, one arm should be a side of the triangle and the other arm should be an extended arm of the triangle. So this is how we determine which is an exterior angle in a triangle. Now there is a very important property with regards to the exterior angle of a triangle, and that is exterior angle is equal to sum of opposite interior angles. Now that's again quite interesting. So let us look at the triangle. So we have this extended arm. So let us name the triangle. Let's say this is A, B, C. Let us call this point as B. So this is the exterior angle. So what is our exterior angle? Angle ACD is the exterior angle. Now this property says that exterior angle is equal to sum of opposite interior angles. So which would be the opposite interior angles for this exterior angle? So we have three interior angles, 1, 2 and 3. So out of these, which two would be the opposite interior angles? This is not opposite because this interior angle is adjacent to the exterior angle. They are located side by side. So when you talk about opposite interior angles, it would be these two angles. So angle ACD will be equal to angle CAB plus angle ABC. So this is what the property is. So let us now try to prove this property, that why this is true. Why is it that the exterior angle is equal to sum of opposite interior angles? So let us try to prove this. So in order to prove this, the first thing that we can say is this angle ACD and angle ACB, these two angles, they form linear pair because they are adjacent angles and they also make 180 degrees together. So we can say that angle ACD plus angle ACB is equal to 180 degrees because they form linear pair. Also, what did we learn in the previous section? We learned that sum of three angles of a triangle is equal to 180 degrees. So that is something which we had learned. So therefore, we can say that angle BAC plus angle ABC plus angle ACB, that is sum of the three interior angles, is equal to 180 degree. So this angle plus this angle plus this angle is equal to 180 degrees. Now when you look at this first equation, this is the first equation. Let us call this equation 1. Let us call this as equation 2. So when you compare equation 1 and equation 2, you see that ACD plus ACB is also equal to 180 and BAC plus ABC plus ACB is also equal to 180 degree. Therefore, we can say that angle ACD plus angle ACB is equal to angle BAC plus angle ABC plus angle ACB. So this ACB, if you transpose it into to the other side, you will get angle ACD is equal to angle BAC plus angle ABC plus angle ACB minus angle ACB. So ACB will cancel out. So what are you left with? You are left with angle ACD is equal to angle BAC or CAB, whatever you call it, plus angle ABC. And this is what we wanted to prove. That is, the exterior angle is equal to sum of opposite interior angles. So basically, sum of these three angles of the triangle is 180. This plus this is 180, and at the same time this plus this is also 180. So we found that this angle is equal to the sum of opposite interior angles. Now see, these are very basic properties of a triangle, but they are very important. Like sum of three angles is 180, exterior angle is equal to sum of opposite interior. Now one very crucial thing that you need to understand here is you should be able to determine the exterior angle properly, because many a times children get confused to find out which angle is exterior angle. So please remember those three important points. Now why am I repeating this is very important. So if you get confused with the exterior angle itself, you will not be able to make use of the properties. First of all, the exterior angle should be formed on the vertex of the triangle. Secondly, it should be located outside. Third, most important point is that the exterior angle's arms, one arm should be a side of the triangle, the other arm should be an extended side of the triangle. So based on whatever we have studied so far, let us quickly look at some of the questions. Question number 1. In triangle PQR, D is the midpoint of QR. That means QD is equal to DR. Right? Because D is the midpoint. So PM is what? So what is PM? So PM, when you look at it, PM is basically a line segment which is drawn from P to its opposite side such that it is perpendicular on the opposite side. So which is that line segment which falls perpendicular to the opposite side? That is nothing but altitude or height. And what is PD? PD is that line segment which joins the midpoint of the opposite side to the vertex. So this is nothing but median. Is QM is equal to MR? Now D is the midpoint. So therefore QD is equal to DR. Therefore QM can never be equal to MR, because this part is equal to this part. Right? So is this equal? No. Why this is no? That's because M is the point where the altitude falls on QR, and altitude doesn't bisect the base. It is always the median which connects to the midpoint. So even if we try to prove this mathematically, we can prove it like this. Now since we know that PD is the median, that means D is the midpoint of QR, therefore QD is equal to DR. So QD can be written as QM plus MD. This is equal to DR. Right? Now the question says, is QM equal to MR? So QM we already have here, but MR we do not have. So how can we get MR? So in order to get MR, we have to add MD to DR. So let us do one thing. Let us add MD on both sides. So what we do, whatever equation, so it is just like adding the same value to both sides of the equation. So this is our existing equation. And what we do, we add MD on both sides. So if we add MD on both sides, what do we get? We get QM plus 2MD is equal to, what is DR plus MD? This is nothing but MR. So what do we see? We see that QM is equal to MR minus 2MD. So what does this prove? This proves that QM is not equal to, therefore QM is not equal to MR. So QM is actually less than MR. So from MR, when you subtract twice of MD only, then you get QM. So definitely QM is not equal to MR. So this is how you can even mathematically prove that the altitude doesn't bisect QR. Question number 2. Find X. So in this diagram, this two angles of the triangle is given and we have to find X. Now can you tell me what is X? Which type of angle is X for this triangle? Is it located inside the triangle? No. So which are the interior angles? This and this. These are the interior angles of the triangle. So X is located outside. It is located on the vertex and it also has one side and one extended side of the triangle. So X is the exterior angle, and by exterior angle property we know that exterior angle is equal to sum of opposite interior angle. So for X, this would be adjacent interior angle. So these two would be the opposite interior angles. So X will be equal to 65 degree plus 45 degree. So this is as per the exterior angle property. So 65 plus 45 is 110 degrees. So X is equal to 110 degree. Let's look at the next one. So here also let's say we have this triangle ABC. So again when you look at X, X is an exterior angle because it is formed outside the triangle and it is formed on the vertex. It has one arm as side of the triangle and the other arm is extended side. So here also we will make use of the same property. So X will be equal to sum of opposite interior angles. So these are the two opposite interior angles. So X would be 60 degree plus 30 degree, which is equal to 90 degrees. So the value of X is 90 degrees. Question number 3. Here also we will have to find out the value of X. So in the first diagram, so which is interior angle and which is exterior angle? So here in this case, these are the interior angles. This is interior, this is interior, this is also interior. But when you look at this 125 degree, this is an exterior angle. So again we will make use of the exterior angle property, that is exterior angle is equal to sum of opposite interior. So opposite interior, one interior would be X. The other interior would be this angle. And what is this angle? So whenever you have an angle represented like this, it is nothing but 90 degree. So this would be X plus 90. Therefore, X will be equal to 125 minus 90. This is equal to 35 degrees. So the value of X is 35 degree. Let's move on to the next one. So here you have an acute triangle where we see two angles are X. So this is also X, this is also X, and this is 50 degree. So how can we find the value of X? So here we do not have any exterior angle given, all are interior angles. And we know that sum of the three angles of a triangle is 180 degree. So sum of three angles in a triangle is 180 degree. So we can write 50 degree plus X is equal to 180 degree. Or we can say 50 degree plus 2x is equal to 180 degree. Or 2x is equal to 180 degree minus 50 degree. So 2x is equal to 180 minus 50 would be 130 degree. Or we can say x is equal to 130 divided by 2, which is 65. So the value of x is equal to 65 degrees. Question number 4. So here also we have a triangle where this angle is given as 90 degree. This is x and this is 2x. So here also we will say that sum of three angles of a triangle is 180 degree. X plus 2x plus 90 is equal to 180 degrees. So x plus 2x will be 3x plus 90 degree is equal to 180 degree, or 3x is equal to 180 minus 90, which is equal to 90 degree, or x is equal to 90 degree divided by 3. So 3 3s are 9, 0, therefore x is equal to 30 degrees. So we again move on to the next triangle where none of the values are given. It is said that all the angles are x. What does that mean? That actually means this is a triangle where all angles are equal. Can you tell me which is that type of triangle where all angles are equal? Exactly. This is nothing but an equilateral triangle. So what happens in an equilateral triangle? So in an equilateral triangle, all the sides are equal, all the angles are equal. However, the angle sum property will still remain the same. That is, the sum of three angles will still be equal to 180 degrees. So this would be 3x is equal to 180 degree, or we can say x is equal to 180 degree divided by 3. So 3 6 is 18. So we can say x is equal to 60 degree. Therefore, the measure of each angle of an equilateral triangle is 60 degrees. Question number 5. So here we have slightly more complicated figures, but however they are also simple. So let us try to find out x and y. So first one, what do we see? We see that x, y and 50 degree, these three are the interior angles of the triangle. So as per the property of triangle, that is sum of the three angles is 180 degree, we can say x plus y plus 50 degree is equal to 180 degrees. Now looking at this scenario, what do you see? You see that this is a line, this is another line, and they are intersecting each other, and y and 80 degree, these are which type of angles? Do you remember which type of angles are they? They are nothing but vertically opposite angles, right? And we know that vertically opposite angles are always equal. Therefore, we can say that y is equal to 80 degree. Now, since we know the value of y, so we can put y as 80 degree in this equation. So, we get 80 plus 50 is equal to 180. So, x plus 130 degree is equal to 180 degree, or x is equal to 180 minus 130, which is equal to 50 degree. So, we get x is equal to 50 degree and y is equal to 80 degree. Let us look at the next one. So, here again none of the values are given. It says that these angles are x and this angle is y. So, here also we will make use of the same property. Which are the interior angles of the triangle? This angle and this angle. Now these two are vertically opposite angles. So here you have vertically opposite angles. So if this is x, this is also x. Similarly here also these two are vertically opposite angles. So here also you have vertically opposite angles. So if this is x, this is also going to be x. Now inside this triangle, which are the three angles? X, x and y. So the sum of three angles of the triangle will be equal to 180 degree. So x plus y is 180 degree. Now when you look at this scenario, what do you see? These two are also vertically opposite angles. Therefore, we can say that x is equal to y or y is equal to x. They both are equal because they are vertically opposite angle. So instead of y, we can write it as x only because x and y are the same. So from this we can say 3x is equal to 180 degree. So x is equal to 180 degree by 3, which is equal to 60 degree. So the value of x is equal to 60 degree. Then what would be the value of y? Y is equal to x. So y will also be equal to 60 degree. So you see, making use of the same properties which we have learnt before, whether it is vertically opposite angle or linear pair or sum of the three angles is 180 degree or exterior angle property. So you need to think about all the properties that you know and then you need to observe and calculate. So what are we going to learn next? Definitely something related to triangle. So you might be thinking, so what am I trying to show you on the screen? There is a school, there is a home. So what am I trying to say? Let me ask you a very simple question from your day-to-day life. Let's say that this is your school and this is your home, as you can see on the screen. And there are two possible routes or two options that you have to return from your school to your home. So these are the route numbers 1 and 2. So these are the two possible routes to your home. So one option is you follow route number 1. That is, you directly come this way. The second option is you start from your school, you go this side and then you take a turn and you come home like this. So these are the two possible routes. So if I ask you, which one would you choose? What would you say? Would you like to go via a longer route, which is route number 2, or a quicker and shorter route, that is route number 1? Which one will you prefer? Of course, you will prefer route number 1 because this is a shorter route. So it might even take you lesser time. So what am I trying to tell you with this? So when you actually look at these routes which I have drawn on the screen, you see that they form a kind of a triangle. They form a triangle, and in this triangle, what we actually did just now was something like this. Let us name this triangle. Let us call this A, B and C. So this is a triangle ABC where we found that route number 2. What was route number 2? Route number 2 was AB plus BC. That was route number 2. And this route number 2 was greater than route number 1. And what is route number 1? Route number 1 is nothing but AC. And this is a very important property of any triangle. And that is what we are going to learn in this section. That sum of two sides of a triangle is always greater than the third side. So that is the property. So this property about the side lengths of a triangle states that sum of the lengths of any two sides of a triangle is always greater than the third side. So let us look at this triangle. So when you take this triangle, as per this property, if you measure the length of the sides, all the three sides, that is AB, BC and AC, you will see that AB plus BC will be greater than AC. Similarly, you will see that AC plus BC will also be greater than AB. You will also see that AB plus AC is greater than BC. So all of these would be true. That means you can pick up any two sides, find their sum, that will always be greater than the third side. And in fact, this is not only true for any particular type of triangle, you can actually try it out. You can start measuring side lengths of different triangles, whether it is a right angle triangle or acute triangle or whichever triangle, scalene triangle, isosceles triangle. For any triangle, sum of the lengths of any two sides is always greater than the third side. Now there is also an alternative way of expressing the same relation. Like as we said that AB plus BC, that is AB, this length plus this length is greater than AC. Now alternative way, so let's write it like this. The alternative way of expressing the same thing is that if we say that AB plus BC is greater than AC, in a way we are trying to say that AB is greater than AC minus BC. That means we are trying to say that any particular side is always greater than the difference between the other two sides. So pretty simple. I mean, both are the same thing. It is not that you need to memorize these definitions. These are not definitions. These are facts. You look at any triangle. Sum of two sides will always be greater than the third side. Now, since sum of two sides is greater than the third side, that also means in an indirect way, it means that if you find out the difference between any two sides, that difference will always be less than the third side. So you pick up any two sides. For example, from the first relation, this was the first relation. From this relation, we derived something like this, which says that any side of a triangle is greater than the difference between the other two sides of the triangle. Right? So do not focus so much on this alternative thing because it might confuse you also. It is just that two sides sum greater than the third side. And indirectly that means the same thing, that the sum of the one side is always greater than the difference between the other two sides. So I hope this is pretty much clear and it didn't create any confusion. You look at any triangle, sum of the two sides is greater than the third side. So without discussing it any further, we will quickly move into the questions, because when we start solving questions using the same property, the concept will get clearer. So let's look at question number 1. is it possible to have a triangle with the following sides? Now you see, this is another interesting thing. Now we can tell even without looking at the triangle. So you do not really have the triangle. Just by looking at the dimension of the sides, you can tell whether you can draw a triangle with these numbers or you can't. That's so interesting, right? So just because you know this property now, that sum of the two sides must be greater than the third side, only then you'll be able to make a triangle out of it. So here you have 6, 3 and 2. So what we will do is, we will try sum of two sides and we will check if it is greater than the third side or not. So let us start with 6 and 3. So 6 plus 3. What is 6 plus 3? It is 9, which is greater than the third side, that is 2. Now let's try with 6 plus 2, which is 8, and this is greater than the third side, that is 3. Now let's try with 3 plus 2, which is 5. Is it greater than 6? It is not. It is less than 6. So that means in this case, looking at this, the condition is not satisfied. So here, sum of the two sides is not greater than the third side. Therefore, drawing a triangle with these three sides is not possible. So if you want, you can actually try it out. Take a ruler and draw a line of 6 centimeters. Then you try to draw a line of 3 centimeters. And then you try to draw a line of 2 centimeters. And you'll see that they'll never meet. They'll never form a triangle. So they will always remain somewhat like this. So you try it out yourself. You try all possible orientations and you will never be able to come up with a triangle. So this is one very interesting thing, isn't it? That you have just the numbers or just the lengths of the sides and you can decide whether you'll be able to make a triangle out of it or not. Nice. So let's look at question number 2. AM is the median of a triangle ABC. So we have to tell, is AB plus BC plus CA, that is sum of the three sides, is it greater than 2AM? So sum of the three sides greater than twice the length of the median. Is this true or not? So let us see. Let us try to prove whether it is true or false. So what do we know about median? Now what is AM? AM is a median. And what does a median do? A median divides a triangle into two smaller triangles of equal areas. That actually means that it divides this bigger triangle ABC. That means the triangle ABC has been divided into two triangles. That is triangle AMB and triangle AMC. So that is what the median has actually done. It has divided the bigger triangle into two smaller triangles. Now let us focus on this smaller triangle AMB. So in this smaller triangle also, the side lengths property should remain the same. That is, sum of the lengths of two sides must be greater than the third side. So in this triangle, we can say that AB plus BM is greater than AM. That is, this side plus this side is greater than AM. Now why are we keeping AM on the right hand side? Because what we have to prove is also on the same lines. So something that we need to prove, there also we see that AM is on the right hand side. So that is why we have taken it like this. AB plus BM is greater than AM. Otherwise, this relation is also true, that AM plus BM is greater than AB. But we are not taking it that way because this is where we want to reach. So we kept AM on the right hand side. In a similar fashion, if we focus on triangle AMC, here also we can say that sum of AC and CM will be greater than AM. So we can say AC plus CM will be greater than AM. So this is equation 1. This is our relation 2. Now if we add 1 and 2. So how do we add 1 and 2? We add left hand side with left hand side. We add right hand side with right hand side. Right? So left hand side will become AB plus BM plus AC plus CM. This is greater than, right hand side would be AM plus AM, that is 2AM. So on the left hand side we have AB plus BM, which is this part, BM, plus AC, which is this part, plus CM. So basically BM plus CM is nothing but BC. So BC is equal to BM plus CM. So here this BM plus CM can be written as BC. And other than that we have AB, other than that we have AC. So basically what is the relation that we have obtained? We found AB plus BC plus AC is greater than 2AM, and that is what was asked in the question, where if this is equal or not. So we can say that yes, this relation is true. Question number 3. ABCD is a quadrilateral. What is a quadrilateral? Quadri, that is 4. So any polygon with 4 sides is called a quadrilateral. Is AB plus BC plus CD plus DA, that is sum of the 4 sides greater than AC plus BD, where AC and BD are the diagonals of the quadrilateral. So here also we will follow more or less the same approach. So you see the diagonals, they have actually divided the quadrilateral into smaller triangles. So you have triangles like this ABD, ABC. You also have smaller triangles like this. So if you call this as point O, so you even have triangles like this AOD, AOB, etc. So here, since we are dealing with the sides and the diagonals, so we will consider those triangles which involve the side and the entire diagonal. So if we take the smaller triangle, it doesn't involve the entire diagonal, right? So let us opt for the bigger triangles like this. So let's say if we consider ABD, so it involves the diagonal, it also involves the sides. So let us talk about triangle ABD. So in ABD, the property that sum of the lengths of 2 sides is greater than the third side is true. So we can say AB plus AD is greater than BD. So this is our first relation. So here also if you observe, we are trying to keep the diagonals on the right hand side. Similarly, let's look at triangle ABC. So here AB plus BC is greater than AC. So likewise, we will focus on triangle ACD. So in ACD, we see that AD plus CD is greater than AC, which is our equation 3. And finally, in triangle BDC, we find that BC plus CD is greater than BD, which is our equation 4. So now what we do as expected, so we are going to add up all of these. So what we will do is we will add 1 and 2. So when we add 1 and 2, what happens to the left hand side? So on the left hand side we get AB plus AD plus AB plus BC plus AD plus CD plus BC plus CD. So this is what we get on the left hand side. This greater than BD plus AC plus AC plus BD. So on the left hand side what we get is, we see that every term is repeated twice. AB is 2 times, AD is also repeated 2 times, BC is repeated 2 times, CD is also repeated 2 times. So basically we can write it as 2 times AB plus BC plus CD plus AD. So this is our left hand side. And on the right hand side we see that AC is repeated 2 times, BD is repeated 2 times. So here also 2 times AC plus BD. So this 2 and 2 will cancel out. So what do we get? We get AB plus BC plus CD plus AD is greater than AC plus BD. So that means yes, this relation is also true. Question number 4. The lengths of 2 sides of a triangle are 12 cm and 15 cm. Between what 2 measures should the length of the third side fall? So in this case, 2 side lengths are already given. So we have to determine the third side length, and when we know that these 3 sides are going to form a triangle. So we will follow the same logic. That is, sum of 2 sides must always be greater than the third side if these 3 sides are going to form a triangle. That means, let us say that the length of the third side is x. So let us say that the length of the third side is x centimeter. So as per this property, the sum of these 2 sides, that is 12 plus 15, should be greater than x, or we can say that 12 plus 15 is 27. So 27 should be greater than x. That means the value of the third side should be less than 27 centimeters. So that is one relation that we have developed. Now, is there any minimum value of x that is also needed? Of course, there is a minimum value as well, because in this case, we are assuming that the three sides of the triangles would be 12, 15 and x. So, the way 12 plus 15 should be greater than x, in a similar way, 12 plus x should also be greater than 15, because sum of any two sides should be greater than the third side. So, from this you can say that x should be greater than 15 minus 12, or you can say that x should be greater than 3. So, this is another relation that you have established. So, from these two relations, you can say that the value of x should be such that it should be greater than 3, but it should be less than 27. Therefore, the range of values that x can take is from 4 centimeter to 26 centimeters, because it cannot take the value of 3 centimeter. It should be greater than 3. So, it can be either 4 centimeter or it could be maximum 26 centimeters, that is less than 27. So, in this fashion, if we know two sides of the triangle, we can even determine the range within which the third side should fall so that the three sides can make up a triangle.
I hope you found the video useful, and if you really understood the concept well, do write in the comment section that concept hua crystal clear. And I will see you all very soon with a new topic and a new video. Till then, take care. Bye-bye.